Assalamualaikum and very good morning to all my fellow friends, to all the viewers, and to Sir Amar Faiz bin Zainal Abidin. My name is Muhammad Shazwan Saifuddin bin Saluddin. I'm from section BEI, section 2, underscore 1. My magic number was B08211048. For this subject, BEEA 2383 Subject Control System Fundamental. This is the individual assignment that I have provided for me to do the past year question. So I choose past year question from BETR 2383 from year 2015 and 2016, and the question that I choose was question number 4. So today we're going to discuss about the question a little bit, and we're going to go through the question one by one, and I'm going to try to explain as best as I could. Okay, so we're going to start. So the question that I choose was question number 4, which is the question number 4 basically covering the mathematical modeling. So the first question, as we can see here, the first question here, the question asks, define the mathematical modeling of control system. Okay, so the mark here was 2 marks. So the answer that I got from the slide, and I asked Sir Amma by myself, when it was 2 marks, so the answer must be simple, but at the same time same as the theoretical that we learned from the slide. So the answer for define the mathematical modeling of control system was mathematical modeling is a representation of a physical system to its mathematical equivalent. So the keywords here just physical system, and number 2, mathematical equivalent. If we understand the concept, we just need to understand these 2 keyword to answer the question. So if the question asks what is mathematical modeling, so just answer by representation of physical system to its mathematical equivalent. So the 2 keywords here is physical system and mathematical equivalent. So right here we get 2 marks. So we go through the second question. The second question, I will read it first. Figure question 4b shows a temperature process control. The process requires the liquid temperature data inside the tank to be held constant. The follows are the description of the process. Voltage ER is an input reference. The liquid temperature inside the tank is measured by a thermocouple and it is labeled as theta. Voltage EB is an amplified voltage produced by the thermocouple, where EB equal to KB theta. Then voltage ER and EB are compared to produce EC. Voltage EC will be used to actuate the heater that will heat up the liquid when necessary. The actuating signal EC is amplified to produce EI. Voltage EI will act as a voltage supply and it will produce current IL. The heater element has a resistance R and inductance L. Temperature of the tank theta is directly proportional to the current IL with a delay d theta divided by dt plus A theta equal to Kc IL. Right? So when we see the figure right here, so the figure show figure show right. As we can see here, the figure, we can see a thermocouple. Other than that, we get tank, we get heater right here, we get amplifier, we get supply, we get amplifier. So the question want us to draw. You can see here, draw a block diagram. Okay, draw a block diagram showing of each component of the system, and you can see the mark here was 5. So when the question asks a block diagram, and as we can see here, we're going to go through the answer. Draw a block diagram showing each component of the system. So this is actually the real block diagram of the system. When we talk about it, we must have first of all, we must have 6 elements. 1, 2, 3, 4, 5, and 6. Okay. So the first one was input. Input. The second one is output. Alright. The third one is controller. Fourth one is actuator. Fifth one was plant. And the sixth one is sensor. Alright. So first of all, how to draw this block diagram. Alright. So we must know that it has to be 1, 2, 3, 4. 4 boxes. 1, 2, 3, 4. So draw the 4 boxes first. Alright. Draw the 4 boxes first. And then we go through 1, 2, 3, 4. Alright. So make the error. Make sure the error from input is going through output. So the error must be like this, like it's shown in the answer. And the end is go back to the sensor, and the sensor go back to the input. Alright. So when we talk about input, first thing is make sure we have the word desire. Alright. Desire is must have. Okay, input, desire. And the second one for the output, remember output must have an actual liquid temperature. Okay, input is desire, output is actual. Okay, so the second one is controller, actuator, plant, thermocouple. For input, make sure what is the question asks you. For an example, for this question, desire what? Desire, we read the question again. The process require the liquid temperature. Alright, so just right here. Desire plus liquid temperature. Same goes as output. So actual what? Actual, the same thing. Liquid temperature. Just right there. Actual liquid temperature. Okay, this is so easy. So for the controller, controller is the one that control the system. So from this figure, you can see here the middle one is amplifier, Ka. Alright, so we write here amplifier, actuator, was the heater, the plant was the tank, because the plant is actually the object for this experiment, so it's obviously the tank. And most commonly the plant was actually mostly before the actuator. Alright, so like like this here. After actuator, heater was tank, the nearest one. So we're gonna put it down here, heater and tank. Okay. And last but not least, the thermocouple. Thermocouple is the sensor. So what is sensor? The sensor is from this paragraph, we can see the liquid temperature inside the tank is measured by thermocouple. Right. So the thermocouple is the sensor, right? So we settle for A1, A2, we're gonna A and B1. So we're gonna throw the next question. Okay. Second question is asked, determine the transfer function for each block. Determine the transfer function of each block. Alright. So like here, transfer function we get from the graph, from the figure, from this figure. Okay, this figure one. Alright. So from the figure, we pull out the formula. Voltage input, the first one, voltage input, right? EC divided by ER minus EB, VC S minus divided by VR time S minus VB time S, and the last formula will be 1 per R1. Okay. Okay. And the second one was amplifier to input. So we just write down EI by IC BIS BCS, and we get the KA. Alright, amplifier from this one. Alright, this one is actually the amplifier. Alright, and after that we get the heater. Heater, we must write down ILS VIS 1 plus RA 1 divided by RA plus LAS. And for the tanks also the same, theta S divided by ILS, and we got KC right here. And the thermocouple is also the same, theta S by ATS and KT. And the amplifier, IT divided by VB. We get the answer was KB. Alright, this is actually all the answer for transfer function for each of this block. Alright, and the mark here was only 5 mark, so it's we must put the all of this formula. Alright, and the third question asks us to find the overall transfer function of the system. Alright, so for the find the overall transfer function, only 3 marks. 3 marks right here. So the answer, we must write down the formula CR like this one, and after that we write down all of all our formula from this above, everything from voltage input, amplifier to input, heater, tank, thermocouple, and amplifier, and you write down all together. So just cut down the which that we found was the same, like this. Alright, minus S VC VI VC IL VI IL, IT, and IT. Alright, so we just write down the left one, S, VR, and VB. Okay, so the final answer was theta S divided by VRS minus by VBS. Okay, um, so the final question and the most highest mark was determine the transfer function for the network shown in figure question 4c using mesh mesh analysis. So as you can see here, the marks was 10 marks, and mostly all of the question, there must be at least one question that have 10 marks. So for this question, the most higher marks was this question. Okay. So as you can see here, the question, determine the transfer function by using the mesh analysis. Determine the transfer function by using the mesh analysis. Okay. So the mark was actually 10 marks. So we're gonna put down the solution first down. First thing we must write down, redraw the figure. After we redraw the figure, we put out all this unit. Make sure there's nothing left over, because we're gonna make a simple mistake. The common mistake that student done in the past year is actually not redrawing the graph, redrawing the figure. So they a little bit confused, and at the same time they just can't answer the question. So make sure we must redraw the figure, right? So write down the formula: VIT1 CI DI per CI, like this, and after that DT plus R1 IL times IT minus by I2 times by IT. After that, we get the second things. Make sure VI S minus by ILIS and plus by 1 and IS minus by I2S. Make sure we're using the mesh analysis formula, and after that one, you can see right here, just do the same thing, and after that 0 equal to R1 I2T minus by ILT plus 1 C2 DIT DT plus R2 I2T. Alright, and then 1 I2S minus IS plus 2 divided S I2S plus I2S, and then negative 1 ILS plus 2 per S plus 1 plus 1 plus I2 plus I2S. Okay, after that negative 1 I1S plus 2S plus 2 times by I2S, and after that we're using the matrix. Actually this have a metric right here. So this should be like 1s plus 1 negative 1 negative 1 2 per s minus plus 2, sorry, and I 1s I2s equal to vi s and 0. Alright, settle this one. After that, use the same one, 1 per s plus 1 v1, sorry, s 0 negative 1 1s plus 1 negative 1 negative 1 2s plus 2 equal to 0 minus negative 1 vs 1 per s plus 1 2 3 plus 2 minus negative 1 power by 2 and lastly vs divided by 1 per s plus 1 2 3 plus by 2 minus by 1. Alright, so this answer we must make sure we write it by, we log it by number 1. Alright, because we're gonna replace it number 1 and then number 2. Okay, so make sure you guys log this one by number 1. Alright, because we're not done yet. And after that, after we got the final answer, we write down like this: VO R2I2S equal to I2S. Alright, and this is what I'm talking about. This one is number 2. So remember, this one number 1 and this one is number 2. Okay, so the last thing to do is replace the number 1 in number 2. Alright, replace number 1 in number 2 like this, and we'll just write down the formula: VO VI S 1 per S plus 1 to 5 plus minus plus 2 and minus negative 1, and this is the final answer: VIS 1 per S plus 1 2 per 5 plus 2 negative 1. Alright, so this is the final answer. Okay, this is final answer. Mostly mistake that student will done is not write down the number 1 and number 2, so replace it like this. So make sure you must be aware, because this total mark will be 10 marks. Okay, 10 marks is such a huge mark. So this type of question is always gonna show up in final exam. So I really hope the student or my friend who watch this video will take note and make sure don't do the same mistake as the past student does, because it's gonna affect your mark. So that's all from me. I just want to say thank you so much for watching my video, watching my explanation. I'm sorry if it's not good as you might think, but I try my best. And I want to say thank you so much to Sir Amma, because giving me a chance to learn this subject, even though the subject was a little bit difficult, but I try my best to understand my own way. So if you want this question, you can oh yeah, this question you can download in the link they provided later. So make sure you want to study, you can see this video. Make sure you just study before the final exam. That's all from me. Thank you, and see you guys real soon. Assalamualaikum warahmatullahi taala wabarakatuh.